Okay, so I guess thanks everyone for coming. And well, we will have Professor Sarah Eskew from University of Tennessee Southern to give us a talk about modeling pre-calculus using a HiMCM problem. And thank you. Let's get started.
All right. So this is me. I'm going to talk about incorporating a modeling project into my pre-calculus class, starting using a high MCM problem. And this is largely based off of, or it started with participating in a workshop hosted by a lot of the applied math groups that run these contest problems, math models. .org. Simeo, Brian was part of one of our mentors as well. Um, and it just started as an idea to get modeling projects into courses. And we're going to talk about what I did for this second one and what I put into my pre-calculus class. Um, so COMPOSTE, in terms of like what it stands for, was converting modeling problems over to student experiences, is what they decided it was called. It was a great, wonderful 7-week workshop that really kind of kicked off this passion project of mine and getting all of these things into like my regular classes. So I was really grateful to be able to participate in that. So I can't like claim credit for these ideas. They were largely built up from this workshop, but I'm going to talk about what I managed to do. We were adapting old modeling contest problems, specifically for undergraduate coursework. So taking those crazy in-depth involved, especially the MCM problems can get very lengthy, and turning those into something that you could incorporate into a classroom setting. And it was great to get in and talk to other people, see what they're doing in their different classes. It is amazing to me how different modeling courses can be from like semester to semester or university to university, and just hearing all of those ideas was fabulous. So during the workshop specifically, I worked on developing a activity that I could use for my special topics modeling course that was going to be running the next semester. That's what I focused on there. I've given a talk about that before, and I'm happy to talk about that later, if anybody's curious about that one. But what I really wanted, and the thing that is important to me, is to be able to get this modeling activities to some extent into our general education courses. I do not have the luxury of teaching differential equations or modeling or any of our like math major courses very often. Most of our upper division courses run on a 2-year rotation. But I am teaching college algebra and that level material 3 or 4 times a semester. So like that's where my heart and time is usually spent. So I wanted to do something for my pre-calculus class. They're slightly more advanced students. They are all in there because they're either going to calculus or they're a STEM major. So it's felt like a good time to start something for them. And the one I chose was actually one that they had pointed out to us in the workshop, which was the HiMCM, which is the high school version of the math modeling contest. Problem B, which was all about carbon dioxide and global warming. In general, students were provided basic information about the carbon dioxide levels and then asked to address some claims or predictions that were made by a magazine or a news article or something like that, in regards to what the future carbon dioxide levels might be. There was a second component of the original project, of course, that used to consider how temperature and the carbon dioxide levels were related. That part of the problem I completely ignored for this particular project, just because again, getting it into a classroom setting, something that students could largely do on their own outside of class, to help them get a little bit of this modeling experience underneath their belt. So one thing when I do these, I always like to talk about why I chose this problem. There are a lot of these different modeling contest problems from different organizations all across the internet, and you can find all kinds of things. Some of them are very, very involved. Some of them take a lot of background knowledge that students in pre-calculus are not going to have. Specifically, that's why I went for the HiMCM problem. So the high school level contest made more sense for students who are basically doing algebra related material. They haven't had calculus, they haven't had any experience modeling before, or and again, a lot of them really did actually struggle with the prereqs to get into this class. Ben's here. Various regression models were discussed as part of the class, as part of our pre-calculus class. I've really tried to incorporate regression as something they at least know how to do, even if they don't know a lot about like what they're doing. They know how to use technology to get those models. So this particular problem provided the data that would then allow us to kind of work with those. So that's one reason I went with that. The data was provided, which is a big help for me as the professor and just easier for the students if I can say, here, use this data. I at least have a general idea of what to expect the answers to be in that situation. So it's just more manageable across the board. Our pre-calculus class, a couple of just notes. It is a 5 credit hour class that covers algebra and trigonometry content. We meet every day of the week. It's a fun class, but there's a lot of content. So this is the application project for the algebra half of the course, essentially. They are largely biology and chemistry students. We're getting more and more computer science students who are needing to get into calculus in the fall, but largely biology and chemistry. So the global warming aspect seemed to fit and at least hopefully be something that they're in their wheelhouse a little bit more so that the content makes sense. Another thing that I really like about especially pulling some of the older MCM problems or HiMCM problems, we can compare to current numbers. So once they get their model, once they get everything set up, they can see how accurate it is. They can see how good their model was able to do based on what current numbers are. So again, just a couple years out from what the data was presented in this problem, but comparisons are still possible. And for me, I actually made very few changes to the actual problem in this case. The other problem that I did for my modeling course, I made a lot of changes. I broke it up into a lot of different pieces and had a lot of different requirements. This one, I took part of the as presented problem. So we only looked at the trends in the carbon dioxide levels, which did not address all parts of the original problem. I would like to maybe make a part 2 assignment that incorporated some of that, but that's down the line. We were able to use technology that we discussed in class. So instead of I told them specifically, like, here, this is what we used in class because we used Desmos for our regression models. I let them use Excel if they wanted to. I'm waiting for one of my computer science students to come in and be like, can I use Python? And I will let them, but that hasn't happened yet. But so use a technology they're familiar with, so that's not part of the learning curve, and just really getting them to focus on the modeling part of the project. I did, like I said, add the component to compare to like today's real data. So they do have to go find the information for today's time frame. So when I did this last year, they went for the 2024 data. This year, it'll be different because I'll make them find the, again, updated data for this year. And so I give them a couple places, hints of what they can do to go find that, but they do have to do a little bit of research there. The presentation component, obviously I did not have these pre-calculus students write a 25-page like report like you do for MCM, but I did have them still do that general audience explanation that this particular problem had included. So you have your main report, and then you also have this like article that is supposed to explain your results to the general audience or wider population of people. And the other thing that I did just in terms of how I presented the problem to the student, I followed kind of roughly the transparency tilt framework that I try to use anytime I'm doing one of these bigger assignments or projects or applications for my students, because transparency is big. So really explaining the task in a little bit more detail and giving very clear expectations for how I was going to grade the project. In terms of the modeling that I was actually able to include, again, this isn't maybe a true modeling problem because there was a lot of guidance. They are, again, pre-cal students, and I need to be able to grade these relatively easily and uniformly across all students. But I did try to keep some level of they had to choose what to do and they had to answer some questions that maybe didn't have one right answer, or there wasn't exactly one right process. So they really did have to kind of defend choices that they were making. And even though, again, I told them they specifically had to form 3 different regression models, I wanted to see the linear, quadratic, and exponential regressions. They had a lot of freedom after that to make to answer the questions the way that they felt made more sense. They had to determine which one was the best one on their own, and they had to, again, deal with data. So the data was given to them. They didn't have to go find it for the most part, but I have found that a lot of students, like even just dealing with a data set that is more than like 10 entries in it, can be really problematic for them. Even in my more advanced classes, they don't always know what to do with large amounts of data, and just having to wrestle with that, I think was beneficial to them. Again, a lot of them are in lab sciences, and they're going to have to deal with that in their future. And there definitely wasn't just one right answer for a lot of the questions that I was, again, using to guide them along the way. And now for the fun part, how it went. In some ways, it went a lot better than I expected. So the very first run through I did of this project was last spring, about this time. So I'm getting ready to assign this project for the second time because I'm teaching pre-cal again this semester. But it went better than I expected. The math part of the project went surprisingly well. Students, for the most part, were able to find their regression models with the data, were able to get the graphs that I was asking for, were able to even decide which one was better pretty well, and defend that better than I expected. Because I really didn't give a lot of guidance. I just assigned the piece of paper and let them work with that. And I do actually have, I was going to share the link. I think with this link, you will be able to access the Word document itself. It is a Word document. I hope it works. If it doesn't, I'll try to share the file. But they were able to find the models. So they were able to largely do the mathematics correctly. But there were still places where I was not fully happy. And that largely came with the communication side of the project, which I was, I guess, kind of expecting. But also I think I do take for granted students' abilities to like read and write and answer the questions you actually ask them to. So the idea of having a written report and this general audience article that was separate I did not do a good job like clearly addressing that. So a lot of students did not understand, like they needed a full written report with all of their information, plus this extra thing that didn't necessarily need all of the stuff because they were explaining it to, a friend in the hallway kind of thing. And the other big thing that I really noticed a lot of students having trouble with was just like writing and using math in their writing. So writing and typing. So obviously a lot of these students have never had the opportunity or need to type mathematics. So a lot of them were very unsure how that worked. I was not expecting students to be completely unaware of like the insert equation button that lives in Word. And for students who use Word all of the time, I was surprised at that. And I was also, again, surprised that they just didn't know how to incorporate both of those things at once. And again, the writing skills also maybe lacking, but we can't We can't fix everything. So that's where we were at after the first run. Again, I enjoyed it enough. I thought it was successful enough that I'm doing it again. I'm at a conference talking about it, and I'm doing it again, but I am going to make some changes to what I did. So I was not able to, my modeling course hasn't run for a second time, but my pre-cal class is running. So this is the first time I'm actually getting to update and change one of my like adapted problems into something new. And so the things that I'm really hoping to change, I hope to spend maybe even a full class period talking to my students as a preparation. So last time I taught the class, I basically just gave them the assignment. We looked at it a little bit, but that was kind of it. And I realized that I think they need a little bit more guidance up front, just in terms of expectations and what I want to get. That way I do actually get what I'm looking for. I haven't figured out exactly how yet, but make a very clear delineation between written report and like explain this to your friend in the hallway kind of thing. Again, I think that was the biggest thing that I didn't get what I wanted on that front. So I'm gonna work on the instructions a little bit there. And then they definitely need more information about what it means to write a paper. I am catching a lot of freshmen and sophomores who haven't had a lot of their technical classes yet. They've had like English composition and maybe aren't even done with that sequence yet. And so I really wanted to try to spend some time talking to them about what that means, to up the communication element a little bit. Because again, the math went well. Of course, that was last time. These students, it might be the exact opposite. We'll see. But I'm really hoping to kind of work on that this time around. The file that I shared in the chat is what the original file from last year. I have not made the official adjustments yet. But that's where I'm thinking about what I'm working on, to hopefully make that better. And because, again, like I said, this idea has become something that I've been really working on and thinking about. And it's a very approachable way to get modeling problems and projects into different courses, modeling courses for one, but also, differential equations or even like calculus and the gen ed level material. And so every time I talk about this, I'm like, please, 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 like, this is a great place to start. So find those old contest problems. Again, MCM is a great one. They have a problem database. They update it every year. SciM's M3C website also has a lot on modeling, and the technical computing resources and practice problems and old challenge problems, that are different and fun. Some of them are more accessible than others. I've had students pull those for different projects. Some of them it's really hard to find data for. So just keep that in mind. But some of them, again, data is provided, links and information, resources all provided. It's fantastic. And the COMPOSTE was really a great place to get me started on this, and I'm very grateful. And I see Ben is in the chat, and he was one of the ones that was part of the workshop as well. And so that's all I have just in terms of like information. But I would love to, again, discuss if you have any suggestions on how to convince students to type and write math and communicate math better. I'd love to hear it, because I'm willing to try pretty much anything at this point, to get that improvement there.
Thank you very much. This is